one of our most important systems with which we interact with the world and with all the food that we ingest, that it's in a homeostatic balance. And at the gut level, this means several things. It means that the gut-associated immune system, which is just microns underneath the lumen of the gut, is in a non-activated state. It means that the permeability between the lumen of the gut and the immune system is not compromised. And that implies that the mucus layer that lines the gut actually means two things. It means that the mucus layer that lines the gut epithelium is intact. And secondly, it means that the tightness of junctions between epithelial cells is high. So microbes or microbial products cannot directly access the gut-associated immune system. I would say that you could also include the gut motility, that the transit through the gut, and this obviously varies based on, depending on the region within the GI tract, is at an optimal speed to facilitate or optimize absorption. It also means that secretion into the gut lumen of fluids is and absorption. Well, there's a range of diseases. So if you go on the one extreme, the inflammatory bowel diseases, including celiac disease, Crohn's disease, ulcerative colitis, where you actually have a chronic state of immune activation in the gut associated with increased permeability, so chronic engagement of the immune system, chronic exposure to gut microbial products or membrane components. And on the other side, you have the so-called functional or motility disorders of the gut, where it's difficult to really detect any anatomical abnormalities, but you see, patients have symptoms of discomfort and pain and altered bowel habits. And so far, despite intense search, people have not identified causative changes that could explain those symptoms. So a wide range from inflammation, chronic inflammation, to dysfunction without detectable organic findings. So we're just at the beginning, really, of our complete understanding of the gut microbiome and its complexity, with trillions of organisms and hundreds of thousands of metabolites, 1,000 species. So this is a very complex system, and I think we're just really touching on the surface right now in our understanding. But one thing is becoming clear, that the microbes and the microbiome are the major interface between nutrition, the things that we ingest, and the gut, and all the cells within, all the other systems within the gut, the immune system, the endocrine system. So it's almost like you could say the gut microbiome translates the components from food into molecules, signaling molecules that reach the gut first, but also, as we know today, most other organs within the body. So it's, you could say it's a decoding mechanism that translates the information that's stored in food into a message that is readable, understandable by our human cells. Absolutely. I mean, my particular interest always has been the interactions between the gut and the central nervous system. And in that area, there's some concepts have come up based on very provocative studies in experimental animals that these molecules that the gut microbiome produces can have a potential pathophysiological role in many brain disorders, from Alzheimer's to Parkinson's to multiple sclerosis. So there's even depression and anxiety. Well, I mean, if you look at our major problems, global health problems right now in the developed world, particularly, it is obesity, metabolic syndrome, and the consequences of these diseases. It's also the rise in autoimmune diseases. It's the rise in autism spectrum disorders, a slower rise in depression, also an increase in Alzheimer's disease. So we have a range of chronic illnesses that we're faced with that have all increased in the last 60, 70 years, pretty dramatically, actually. And we have no, up to recently, have no good explanation why that is happening, nor do we have very effective therapies for any one of those disorders. If you look at obesity, we don't really have anything that produces sustained benefit. And so the hope is, and the big potential promise is that the alteration of the microbiome is the key to the understanding of all of these. And